Today we're going to be doing some colorful chemistry and learning how to make our own pH indicator. What is pH? pH is a measure of how acidic or basic a solution or substance is, and ranges in values from 0 to 14. Substances with lower pH values are considered more acidic, while substances with higher pH values are considered more basic or alkaline. A pH value of 7 is considered neither acidic nor basic and is thus considered neutral. Let's look towards the acidic side of the pH scale. You can see that stomach acid has a pH value of 1, where soda has a pH value of 3, and milk has a pH value of 6. This means that stomach acid is a stronger acid than soda, which is a stronger acid than milk, which is pretty close to our neutral value of 7. If we now look towards the more basic side of the pH scale, we see that bleach has a pH value of 13, where soapy water has a pH value of 12, and baking soda has a pH value of 9. This means that bleach is a stronger base than soapy water, which is a stronger base than baking soda. One way that we can test whether a substance is an acid or a base is to test the pH. Scientists can either use a device called a pH meter or something called a pH indicator. A pH indicator is a special type of chemical that changes its color in response to different pHs. For example, a pH indicator may turn red when it comes in contact with acidic substances, green when it comes in contact with neutral substances, and blue when it comes in contact with basic substances. By knowing some basic properties about our pH indicator, we can add it to various substances whose pH is unknown and use the color change to help us identify whether the substance was an acid, neutral, or a base. Today, we will harvest our own pH indicator from fruits, vegetables, or plants that we have in our homes. The pH indicator that we will be using today is a pigment called anthocyanin. Anthocyanin is a pigment found in fruits and vegetables like raspberries, blackberries, cherries, or red cabbage, and helps give them their deep purple-red hue. Beyond giving these foods their characteristic coloring, anthocyanin is also sensitive to pH. Anthocyanin tends to be purple at neutral pHs, turns pink upon encountering an acidic solution, and turns green or yellow on encountering a basic solution. Therefore, we can extract anthocyanin from things like red cabbage or eggplant peels. Then, we can use this solution to test the pH of various substances around our house. I had a lot of violets growing in my yard, so that's what I'll be using as my source of anthocyanin here today. However, if you have one of these other fruits and vegetables, you can feel free to use those instead. You will need violets or another food with anthocyanin, a small plastic container with a lid, boiling water, a spoon, strainer or colander, several small clear cups or bowls, and a variety of solutions to test pH. Some things that I suggest are vinegar, fruit juice, soapy water, and anything else that you'd like to try. A few things to note. You'll want to get a parent or guardian's help with the boiling water, as well as if you need to cut up any fruits or skin any vegetables. Let's get started. First, I need to strip off all of the petals from my violets, as this is the part that contains the pigment anthocyanin. I'll place all of my petals in this small plastic container and discard the stems. Once I've removed all the petals from the stems, I will use a small juice glass to grind up the petals even further. This will allow me to extract even more anthocyanin pigment from the petals. Next, I will pour boiling water over the petals so that they are just covered. Give it a mix and be sure that all of the petals are equally submerged in the water. Then, put the lid on and come back in about an hour. Now that it's been an hour, let's check on our progress. We can see that the water has already started to take on a bluish purple color. Next, we need to strain out the flower petals, reserving the water with the anthocyanin pigment. We now have our own pH indicator made from the anthocyanin from violet petals. I'd like to test a few different substances, so I'm going to pour my pH indicator into a variety of glasses. First, I'd like to test some baking soda. Add a small amount of baking soda to your pH indicator and stir. Note the dramatic color change from a deep blue purple to a green. Watch what happens when I add a small amount of vinegar to the pH indicator. You can see that the pH indicator turns a vibrant shade of pink upon adding vinegar. Remember, we learned that anthocyanin tends to turn pink when exposed to acidic substances and green when exposed to basic substances. This means that baking soda is a base and vinegar is an acid. Now that we've made our very own pH indicator, what will you test?